Is y equals negative 2x squared plus 8x minus 3 a quadratic equation? And what does it look like? Well, how about if we try plugging in some values, some random values, such as negative 2, negative 1, 0, 1, and 2. And we'll get a chance to also sketch it. So let's label our x and y axis. Our quadratic equation is in the form of y equals ax squared plus bx plus c. Yep, it is in that format. So let's try plugging in values. That way we can check and see how it works. So wherever we see an x, we're going to plug in the first case scenario of negative 2. That's our first x value that we picked. So plugging in negative 2 here and here, that's where our x's were originally. And negative 2 times negative 2, well, remember, order operation means we have to do negative 2 squared. So let's try this out. Negative 2 squared, negative 2 times negative 2 gives us positive 4, right? And then 8 times negative 2, 16. So there we go. Negative 2 times 4 now will give us 8. There we go. So we now have y equals negative 8 minus 16 minus 3. And now let's add them all together. Negative 8 minus 16 minus 3 will give us a total of negative 27. Whew. That's a huge number. I don't think I'm going to be able to fit negative 27 into my little graph there that only goes up to 10 on every direction. Oh well, we maybe didn't select the wisest values. So recommendation, next time that you graph a quadratic equation, I recommend you plot in your calculator and then pick values for x. It makes it easier. That way, otherwise, you may end up not having anything within your graph that you have there. So let's go for the next one though in this case. Let's continue on. So next value that we picked was x value of negative 1. There we go, substituting on to our original equation or expression. Negative 2 times negative 1 squared, well, first the squares, right, or operation. Negative 1 times negative 1 gives us positive 1. And 8 times negative 1 gives us negative 8. So therefore we have negative 2 times 1 now. Negative 2 times 1 gives us, well, 1. So negative 2 minus 8 minus 3 gives us a total of negative 13. Hey, that's a little smaller, but even now I won't be able to fit in my graph. I don't have enough space for that negative 13 on my current graph. Okay, let's go for the next one then. 0. So negative 2 times 0, well, remember also operation, 0 squared. 0 squared is just 0. 0 times 2 is going to be 0 either way, all right? 8 times 0, still 0. So that's going to leave us with just negative 3. Pretty straightforward. Now I have at least a point that I can fit on my graph there. So far, one of them is going to fit on our graph, I should say. Okay, so let's go for the next one when x is positive 1. So let's fill in our spots. There we go, for the axis. 1 squared, 1 times 1 is 1. And 8 times 1 is 8. So 2 times negative 1 is 2. And then we can add them, right? Negative 2 plus 8 minus 3 will give us a total of 3. Or in other words, 8 minus 5 will give us 3, right? If you combine the negatives first. So there is our next value and one more value that we can actually fit on our graph. So let's fit in our next x value that we picked, 2. There we go. And in this case, we're going to go with 2 squared. 2 times 2 is 4. 8 times 2, 16. So negative 2 times 4 will give us negative 8. Negative 8 plus 16 minus 3, what, let's see, negative 8 minus 3, that's a tough one, 11, right? 16 minus 11 will give us 5. So our answer is 5. Hey, look at that, another point that we can actually plot. So we would be able to plot 3 points out of the original 5 points that we selected. For a linear equation, that would be great. All we need is 2. But for a quadratic equation or a parabola, you need more than that. So I highly recommend you try using your calculator. So let's bring our calculator real quick. So let's turn our calculator, clear anything that we have, and let's go to y equals, clear it out, so push the y equals button, and we're going to graph negative. Has to be your negative sign at the very bottom, right next to your enter button. So negative 2x, then the square button on the left side towards the middle of your calculator keyboard there, squared, so plus 8x. Once again, your x is your alpha button, or next to your alpha button, I should say. 8x minus, that's the subtraction sign, so minus 3. We want to go to zoom and do a zoom standard, option 6. So middle top is your zoom, and then standard would be 6. There we go. So that's why we couldn't get much in the left side. That's because in this case our graph is shifted a little bit to the right. So if you go to second graph, that gives you your option of viewing the table. Since we started with a negative 2 gives us negative 27. That's correct. We got the right answer. Negative 1 gives us negative 13. Yep, that's correct. I'm just checking that we got the right answers. At 0 we get negative 3, correct. At 1 we get 3. At 2 we get 5. And at 3 we get 3. Be aware, if I try going up on the y column, it only takes me up to y, so I wouldn't be able to do that. To go up, you go to the x and push up. To go down, it doesn't matter which one you are in. So at 2 we get positive 5, just like we did. Hey, look at that, we could have plotted more points. At 3 we would get 3, and at 4 we would get negative 3, and at 5 we would get negative 13 again, but that would be too high. So there it is. Those would have probably been the best choice values. So let's fill in a couple more from our calculator. So the 3 and the 4 gives us positive 3 and negative 3. Now we have a couple more dots that we can plot. So now that we used our calculator to aid us with filling in our table to make it a little bit better, we can actually now plot them. So first coordinate that we have is a 0, negative 3. There you go. 0, negative 3. Second coordinate, 1 and positive 3. Next coordinate, 2 and positive 5. Next one, 3 and positive 3. And finally, 4 and negative 3 is what actually we can fit on here. So now let's trace our line to make it look like it's a parabola. This is a rough approximation, be aware of that. In most cases, when we're doing it by hand, all we can do is a rough approximation, unless you get more dots in between and everywhere else. Then you make it more exact. So our parabola, it's a parabola, that's what it looks like. And yes, definitely it is a quadratic equation because it's a parabola. Agreed? So we can probably state otherwise that we have a vertex at x equals 2. I'll draw a quick arrow there for you. There is where our vertex is. And technically at x equals 2 is our line of symmetry. We can do approximate intercepts if we want to do them. There we go. For our x-axis, there are approximate intercepts, y-axis. It'll be right there. And we actually have it. It's a 0, negative 3. Approximate intercepts for x, it would be roughly 0.5, 0, and the other one roughly 3.5, 0. That's as far as we can approximate. I'll get rid of that for that reference though. And let's realize that we could have done much more sketching because we can always do it through our calculator, right? As a reference. So if you started fresh and wanted to graph this one, again, we'd probably start from the beginning and do first a graphing calculator. So if we had start from the beginning, plug it into your graphing calculator, do a graph, that way you can see what it looks like, and then pick x values. If you notice, you probably don't want to pick the negative 3, negative 2, or negative 1 because they're a little high. And we would also probably not pick that 5 at the very bottom because it would be high once again. So good numbers from what we can visually see would be negative 1 all the way up to maybe 4 maximum, ideally, right? And once again, notice that you can actually go into your table. So second graph gives you a table, and you can have even a better view of it, of which ones are better choices, and plug them into your table there. But for this case scenario, we are technically completed.